My name is Francisco Belzagui Elder. I am from the Universitat Politécnica de Catalunya in Spain. And I'm going to present about a new and sustainable filter device that we have developed to reduce the textile microfibers pollution. What will we see? Well, an introduction, what are microplastics and microfibers, some estimations that were made for the microfibers, some solutions that are currently in the market, and our proposed filtering system. In the introduction, what are microplastics and microfibers? I like to use the ECHA definition that is under revision because there's still some uncertainty about what are microplastics and microfibers, but microplastics are little fragments between 1 nanometer and 5 millimeter of non-biodegradable or not chemically modified polymers. Hence, in this sense, rayon or any cellulose acetates are included into the microplastic definition. In the we're referring to the microfibers because of the morphology that they have. It's more about a relation between the radio, between the longitude and the diameter. That it has to be measure of 3 to 1. Then the minimum length is 3 nanometers and the maximum length is 15 millimeters. But microfibers can include also no microplastics. Hence, sometimes it's better to make a brief reference, like, for example, when we're talking about microfibers plastics, to not be confused with other microfibers like
Dr.
cotton.
Francisco, just a moment. Can everyone see Dr. Francisco presentation?
Sir, it is not in presentation mode.
So, Dr. Francisco, can you share your screen again and can you start your presentation once again?
Yes.
Please put it in presentation mode.
It's in presentation mode.
But we are not able to see. It is very small slide.
Can you log out and log in again?
Let me
share your screen now.
Now, can you see it better?
Yes, we can.
Can you see all the?
Yes, we can see everything. We can see your complete screen now.
Do I have to start again?
Yes, you can.
Well, my name is Francisco Belzagui. I'm from the Universitat Politécnica de Catalunya in Spain, and I will talk about a new and sustainable filter device to reduce the pollution of textile microfibers. We will see in these slides, it is a short communication. It's an introduction about what are microplastics and microfibers and a short estimation of microfibers that goes into aquatic environment, the current solutions, and the filtering system that we are proposing. In introduction, well, microplastics and microfibers, I like to use the ECHA, which is a European Chemical Agency definition, which is under revision, that says that microplastics are little fragments between 1 nanometer to 5 millimeters of non-biodegradable and not chemically modified polymers. Hence, in this sense, rayon, for example, or any cellulose acetates are included into the microplastic pollution. On the other hand, microfibers, because the morphology is different, they prefer to refer to them with a radio between the longitude and the diameter that has to be a maximum of 3 to 1. Then, in this sense, the longitude will be between 3 nanometers to maximum of 15 millimeters. Then a microfiber of 15 millimeters can be considered a microplastic microfiber. It should be noticed that any the microfibers also include for example, cotton microfibers that are no microplastics. So sometimes it's better to make a brief reference, like microfibers plastics. In the bottom of each slide, you will see the reference from where I got everything that we will see. In this sense, as you can see here, these are all the textile microfibers are inside the blue box. Before the European Chemical Agency, only the synthetic ones were considered as microplastics. But now they are proposing to consider all that are inside the red box. They are synthetic and the artificial. This is all the man-made fibers. I think that it is correct because, for example, we made some experiments with cigarette butts. They are made of acetate cellulose, and we saw that their degradation was almost. We didn't see any chemical degradation in 1 year. So, well, we also shared the European Chemical Agency definition that the artificial fibers should be included into the microplastic pollution. I'm now talking about estimation of microfibers. It's in Spanish, but it doesn't matter. This is an equation that we use to calculate to estimate the quantity of microfibers. We have the microfibers that are attached from a washing cycle, the effluent of the washing machines. This yellow part has to be with the municipal water that are treated. That only 20% approximately of the world's water are treated. This has to be between the synthetic and natural fibers. It's a proportion, and this has to be about the type of washer, because the top loading washers are supposed to detach more microfibers. So with this in hand and all the data that we had, we calculated how many microfibers are generated in the world. This is a total of 0.5 million tons per year, and that we can also express in quantity of microfibers. And the top countries are, North America, then these ones about here. But because of that some countries, like for example Australia or North America, have used water treatment plants, the quantity of microfibers that reach aquatic environments is different. You can see that, for instance, North America was in first place in the countries that generate textile microfibers. But when we talk about textile microfibers reaching aquatic environments, they go to the 5th place because of they have a lot of wastewater treatment plants. But nonetheless, we have to also the microfibers don't disappear in a wastewater treatment plant. They are only transferred to the sludge. So we are only transferring the problem to another place that we have to see what happened then. Because if we use, for example, that sludge by turning into compost, then the microfiber will still reach the environment. So all these 0.5 million tons of microfibers per year will also reach the environment. Here is a summary of what I just said. 0.5 million tons of year is the total of microfibers generation in domestic washing machine. From there, 0.3 million tons reach aquatic environments, but we have to also know that we are not considering industrial processes or drying or the use of textile garments and their source of microfibers to the air. These are not included in the estimation because we have no data. So it is obviously underestimated, the 0.5 and the 0.3 million tons of year. So further investigation is needed. But the solutions that we are now contemplating are those that come from the washing machine. There are some solutions that I put here. For example, the Cora ball that you put inside the washing machine, and it is supposed that reduce the regeneration of microfibers and to attach the microfibers to the Cora ball itself. The Gapri frame, that it is like a bag where you put inside your clothes and it take care of your clothes. Or the Planet Care or the Lindluth. These are external filters, normal filters like any filters that function because of the size of the pore. There are another ones like the X-Filter that I have not included here, but it's more sophisticated. It has like a pump inside, so obviously it can reduce more quantity of microfibers, but it needs an external use of energy. This is a study, you can find it here. Well, they evaluated some of these devices. The X-Filter is the filter that I just said, that it has an internal pump to so they can pass the water through minimal length form of the filter. But these results are not there is another study that also evaluated some of these devices, and they are currently like do not have the same results. So further investigation is also needed to see what's happening here, no? But the big question is also, okay, we have the microfibers attached to the filter, we have retained the microfibers, what can we do with them? In this in this study, they say that, for example, I don't remember if it was on Planet Care or on Lindluth, that you can remove the microfibers and throw them to the garbage, but it's the same as doing nothing. So we are proposing a filtering system that is under a Spanish patent. That's the number of the Spanish patent, that use all recycled materials as raw materials, use recycled polymer for the shell, and recycled thermoplastic polymers as the filtering media. So it has basically three parts. The first part is to connect it to the washing machine. The second part is to give a space or volume for the water to accumulate and give the time to pass through the filtering section. This filtering section is made of thermoplastic polymer pellets. So it's all made of recycled polymers. It's all made of recycled polymers, which make it more sustainable. The rotation efficiency of this filter is more than 97%. It only uses the hydrophobicity and the capacity of the microfibers to make lint between them. So the efficiency of this filter goes up and up and up between every use. And the most important part is that we are offering a proposal to treat the microfibers, which is once the filter once there is no, you can pass any more flow through the filter, we can take the filtering media and the microfibers and merge them and produce and manufacture some products. We are currently, for example, making in our institute, we are making some carriers for moving bioreactor systems. So with this, this which was before garbage, we use as a raw material to treat now water. And well, that's all. Thank you. If anyone has any question, please ask me. You can also write me here. There is my email address. I will stop